Hi, so let's see the demonstration of PowerMill 2019, the newer version. Today the first section is going to be roughing strategies explanation. So we will see how efficient the two PowerMill 2019 roughing strategies does their work. So let's open up or import the model for today's demonstration. So for that I go to File, Import, select the model, open it up. So this is the model on which we are going to run our roughing strategies or for the entire full demonstration. So I'm going to open up a template form, that is templates and macros or something for that is available within PowerMill on the automation side of it. So it is to simplify or to avoid the repeated activities that we do on everyday basis. So here in this example I have created some pre-created some toolpaths with tools and boundaries, so which I generally use it for any tie and mold applications. So I just open up that template form today. So just for calling the templates, just go to File, Import, Template Objects, select the template, and that's it. So your Explorer button on the PowerMill has been updated with all your toolpaths, tools, and boundaries. So the first one is going to be the roughing. So we can generally just apply. So these toolpaths are predefined with the values for all the parameters. So just we can call the toolpath and apply it. So first one section as of the first one is going to be the roughing. So just I double click on the roughing strategy. Before that I just go to block and define my block. So this is the block that I created, and you can see the block dimensions are something around 500 by 335. So here I'll just go to my settings page of the roughing strategy, and you can see the tool that I'm using that has been predefined for the roughing application is 20. So I feel the 20 is a little bit smaller, so I want to go with a bigger tool. So I can just call it from the tool database. So tool database is something that is available with PowerMill, where you can whatever the tools you create can be saved in the library, and which you can call later for the rest of the projects. So in this case I have already predefined a 50 bool R2 cutter in the database. I just select that one and say create tool, and you can see the tool has been copied to my toolpath. So I just close my tool database screen, and now I am in the toolpath form. So you can see the tool has been replaced. 20 dia tool has been replaced with 50 dia bull. I can go to edit in case if I want to edit something. So these are there. Holders has been defined. If I want to add a holder, I can add it. I can add shanks. Shanks are there. So just select the holders and then say what diameter of holder you want, and then you can also edit your cutting data. Say for example this is a roughing tool, so I say the cutting data, as I can store it. Automatically you can say as for the feed rate, surface speed, and feed per tooth, your spindle RPM, cutting feed rate are populated for this particular tool. So once you are done it, you can again, if you want to save this tool as a new tool in the tool database, you can just click here to create the tool database, or else you can just close it as of now. So now the tool is ready, and automatically you can see once we created the tool with the parameters, those parameters are getting highlighted in the tools in the toolpath forms. So since these things are pre-created, so just let's apply the calculate button, and you can see how fast the PowerMill is to create. Within seconds it calculates the roughing toolpath. Hit up toolpath, done. So the roughing toolpath is done now. So let's see the toolpath. Let's deep dive into the toolpath and see how efficient the toolpaths have been created. Default toolpath itself, very efficient toolpath has been created with PowerMill 2019. So let's compare this efficient toolpath with the normal roughing toolpath that we usually generate in other systems. So I will just differentiate those things. Here you can see first option, it has not entered into the small pocket area. So since this cutter diameter is big and this area is small, Even though the cutter can go inside, the ramping space is not available because we are using a bullnose cutter, which doesn't have a center cutting. Only the edges will do the machining, so it automatically avoids that area. But when you see the general roughing toolpath, you can see it has created the same dia tool 50 bull, and you can see the toolpath has created inside. So if I simulate at this point, so when I say simulate from start, automatically you can see the ribbon interface advantage of ribbon interface in PowerMill, newer versions of PowerMill 2019. When I say simulate, automatically your simulation ribbon interface opens up for you to do a play button. Okay, so that is the advantage of ribbon interface. And you can see, so this tool is almost quite a big enough to enter into this area to do a roughing operation. So it's better to avoid this one, and that's what happens with our high efficient toolpath that is generated generally in PowerMill 2019. And second option that I want to highlight here is the sharp corners here. So wherever there are corner area machining, you can see there are a lot of sharp movements within the PowerMill. Generic toolpath, roughing toolpath will be like this, but our toolpath, you can see it's more radial forms. It has created all the corners as radial fashions. There is no sharp edge movements, so this gives us a more consistent feed rate machining without any chattering marks or uh, jerk motions on the machine. So this is automatically done. High efficiency high speed machining functionality within PowerMill introduces these kind of filleted motions in the PowerMill in the NC program. So these are few advantages. And also the one more thing is that as you create the toolpath itself, since we have defined the holders, so the toolpath has been cross-checked against the holder and the model, and it shows me that tool and the holder are safe as it creates the toolpath itself. But in generic, what happens is you don't have that one, so only it cross-checks the tool, holders are not cross-checked. So now with the high efficient programming, when the holders are defined, we can automatically checks for the holders and creates a safe toolpath that can be run on the machine. And also now with PowerMill 2019, we have got Vortex from stock model. So Vortex is something, this roughing operation is, we use offset all method, which is a stepwise roughing where it goes by 0.5 0.5 depth of cut to do the roughing operation. Vortex is something where you do use a solid carbide tools, and full flute of the tool gets engaged with the material and does a side cutting operation. So that is the Vortex method. So Vortex has long been available with PowerMill. So now with newer version, we have got the Vortex from stock option. Let's see the difference between these two things. So this is Vortex from model. So you can see a single pass roughing operation, and this is from Vortex from stock. You can see completely entirely different trochoidal offset motions between these two things. So this is a newer option in 2019, and that is the older legacy option which was available quite a few years with PowerMill in earlier versions of PowerMill. So what is the main characteristics of these two toolpath forms are that from model follows the complete finished model. Trochoidal offsets are followed with against the finished model, and Vortex from stock uses the raw material, follows the raw material and creates the trochoidal offsets. So, and the main advantage what you find here is the statistics page. You can see this roughing toolpath has taken 1 hour and 12 minutes with stock, and from model has taken 1 hour 36 minutes for the same roughing from the same raw material size. So these are the advantages of roughing toolpath within PowerMill 2019. So the next section is going to be the rest machining operation. So let's capture the rest machining in the next video. Thank you.